Paper Pilot back with another video. Today we're going to be solving another paper of S1 since your S1 exams are coming soon, so I'm going to try to make as much S1 videos as possible. So today we're going to be solving May-June variant 2 of 2024 series. So let's just start. So the first question we have is on a geometric distribution. Alright, so Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3 independently of the other years. This means that this is geometric progressions. Alright, find the probability that Rajesh is successful for the first time on his 7th attempt. Okay, so he basically tries to attempt every year for 7 years, basically 7 times. Alright, he attempts for 7 times, and he finally passes his attempt on the 7th try, but all the other 6 tries he fails. So first of all, let's write this as geometric. Okay, the probability of success is 0.3 and the probability of failure is 0.7. So the first 6 times he fails, so 0.7 to the power of 6, and then he passes. So this is going to into 0.6, which we get as 0.035, right? That is your answer. Moving on, find the probability that Rajesh is successful for the first time before his 6th attempt. Before his 6th attempt. That means he can be successful with his 5th, 4th, 3rd, 2nd, or 1st. We don't know. So basically the way to solve this is you subtract 1 from the probability that he fails on the first 5 attempts, which is basically 1 minus 0.7 to the power of 5. That's the formula for whenever it's less, right? Because this can be written as this: px less than equals to 5. So it's gonna be this. Correct. Alright, 3S, guys. Always write your answers 3S, always. Find the probability that Rajesh is successful. Find the probability that Rajesh is successful on his 10th attempt. Alright. So this time, okay, so the first, right, 2nd attempt. Alright. Okay, we can consider this as binomial actually. Or you guys can think of it as geometric. But either way you guys will say. So on his 10th attempt he passes, but that means before on his other 9 attempts he also passes one of them, but we don't know which one. Right. So hence it's gonna be 9C1, because we don't know out of the first 9 attempts which one he actually passes. But we do know that he passes twice, right? Hence 0.3 square, and the rest 8 times he fails, hence 0.7 to the power 8. This is gonna be his probability. So if we solve this, do it again. We get 0.1556. into 0.3, which is 0.0467. That's your final answer. That's the final answer. Moving on to the next question. So Seva has a coin which is biased, so that when it's thrown, the probability of obtaining the head is 1/3. He also has a bag of coins containing 4 marbles and 5 blue marbles. Seva throws the coin. If he obtains a head, he selects 1 marble from the bag at random. If he obtains a tail, he selects 2 marbles from the bag at random and without replacement. Find the probability that Seva selects at least 1 red marble. Okay, so it's better to make a tree diagram for this. So Actually, wait. It's better to draw it down here. Okay, so what are the possibilities? The first possibility is that he obtains a head or he obtains a tail. Since it's biased, the probability of tail is 2 by 3 and the probability of head is 1 by 3. Right. Now, it says that when he, obtains a head, he selects one marble at random, right? So, it can either be red or it can either be blue. Same case over here, but he selects 2 at random for tails. So basically, and he also selects it 1 by 1, so there is more possibilities than this for tails. 2, 1, 2. Now we have to write down the probabilities. So, wait, let me just write this first though. Okay, so now let's write down the probabilities. So in the bag there's 4, out of 9 marbles 4 are red, right? So we're gonna write out of 4 9 for here, and for here 5 by 9. For tails it's gonna be the same, 4 by 9, 5 by 9. But now over here, since it's without replacement, he already takes 1 red, so 1 is gonna decrease, so it's gonna be 8 over 3. And if this is if this is 3 over 8, this is gonna be 5 over 8. And this will be 1 blue will decrease, the red will remain the same, so 4 over 8 and 4 over 8. Okay, now find the probability that Seva selects at least 1 red marble. Okay, so it can be 1 red marble or 2 red marble. Alright, so let's take all the possibilities. So at least, which means x greater than or equals to 1 red. So if she chooses only 1 red marble, it can be 1 by 3 into, or no, it's a he actually. It's a he, right? Okay, you know what? Who cares? 4 by 9. It's 1 red. Or if he gets tails first and then red, 4 by 9. But there can be more. What if he gets head? What if he gets tail, then red, and then red again? Or there's actually way more possibilities. Or there's another possibility. Okay, I think it's better to, let me shift this on the blank page. That's gonna be better. Wait, let me fix this. Go to the blank page, hold up. Alright, so right here. So these are the probabilities we already know, but there can be one way more. For example, probability that he gets a tail and then red, and oh, we already did this way. What about the probability that he gets a tail, then he gets blue, and then he gets red? Okay, these are all the possibilities. So if we add all them up, we should get 17 by 27, which is the answer. Right. Hope you guys understood that. It was pretty easy. You just have to draw a diagram and then, find all the possibilities, but it's pretty easy. Moving on to the next question. Find the probability that Seva obtains a head given that she selects no red marbles. Okay, so from this diagram again we have to solve this. So the probability, first we have to find the intersection between this, no red. So how can we do that? Select head, but no red, which basically means blue. So 5 by 9, just 5 over 36. No, sorry, 27. 5 over 27. Now, probability of no red is, let's just say, no red. No red is, it can be head or no red, which is 5 over 27. Or it can be tails and then blue and then blue. So if we add this, we get 10 over 27. So probability of head, no red is 5 over 27 divided by 10 over 27. Solve them, we get half, which is the answer. Pretty simple, guys. Now next question, we have a normal distribution question. So the mean is given, the standard deviation is given. Oranges are classified as small, medium, or large. A large orange weighs at least 184 grams. 20% of oranges are classified as small. Find a percentage of oranges that are classified as large. Okay, so it's classified as either small, medium, or large. So a large, probability of large, we don't know, but we do know probability of small is 20%. Okay, so we know that at least 184, so we can write greater than 184 is large. Let's solve this. Set greater than 184 minus 131, 0.9815. Let me first write that this is normal distribution. This also carries a mark, guys, so don't forget to write this. Okay, so this is gonna be z greater than 0.9815. Okay, let's actually draw a graph real quick for this. So 0.9815, this is on this side, and we have to say this greater of this. So we can just subtract this from 1 minus this 0.9815. Using the calculator or MF19, you get this value. If you subtract that, this is your probability. But we have to write this as a percent, so just multiply with 100, and the percentage you get is 16.3%. 3SF, guys, so yeah, one answer done. Now, moving on to the next question is find the greatest possible weight of the small orange. So the probability that the orange is small is 0.2, 20%, so 0.2. And out of, okay, normal distribution 131 grams and standard deviation is this. The orange is classified as small, medium, or large. Large orange weighs at least this grams. Okay, so we don't know how small this is. So how about let's just write, we don't know what's the grams, So let's just say let weight be S for small. Let's just think of the range as S. So if it's S, then it should be less than S because it's small. It's equals to 0.2. So let's try solving by that. S minus 131 by 54 equals to 0.2. It's less, okay. Let's draw a graph. So from here it is 0.2. This is less than 0.2, which basically means the same as this. This is gonna be negative z. This part is also 0.2, and this part, this whole thing over here is 0.8. Which means that your 0.8 is this 0.842. Yeah, which we already got here, I think. Wait. Okay, wait, guys. Let me just think about this real quick. It's possible way of AS is here. We know the probability is this 0.6 this. Okay. Okay, guys, I think I figured out how to do this. It says greatest possible range. Right. So it has to be less than S, which means that, yeah, less than S. So how can we do this? So this, from this equation, we know that S minus 131 by 54 is going to be 0.2, and if we inverse 0.2 we get this 131 by 54 is equals to negative 0.842. Now you guys can retrace using MF19, or I would personally use a calculator to do this. Either way you should get this value. Now if we solve for S, what do we get? We get 85.532, which we have to round it up 3SF to 85.5 grams. Yeah, that's your answer. Okay, not tricky, but I would say this, you just have to think a bit. But honestly, if you form this equation from here, it's really simple. Right. So next question we have is a stem and leaf back-to-back diagram. Okay. So the back-to-back stem and leaf diagram shows the annual salaries of 19 employees at each of the two companies, Petrol and Raven. Keys given: 31.5 is 31,2000 for Petrol, and 31.5 is 31,000 for Raven employee. Okay, find the median interquartile range of the salaries for Petrol employees. All right, so we're given the graph to find the median. So it is total 19. That means 19 by 2 is like, so either it's like from the 9.5, so between the 9th and 10th term over here. So 1 2 3 4 5 6 7 8 9. 2 3 4 5 6 7 8 9. 1 2 3. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. Okay, so what is the mean going to be? The mean should be 2 3 4 5 6 7 8 9 10. If we take 0 as the median, does that work? 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. Okay, yeah, so the median is basically this, because over here it's 9 values, over here it's 9 values. This is the median. So the median is going to be 320, so $32,000, right? This is the median. Now I have to find IQR. So how can we find IQR? IQR is IQR upper quartile minus lower quartile. So the upper quartile we can find is the median of this. Lower quartile is the median of this. So from here, what's the median? The median over here is going to be 1, 2, 3, 4, 5. Over here, it's going to be 2. While for the upper quartile, the median should be 5. Yeah, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it's 5. Okay. So the upper quartile IQR is going to be 333. Just actually erase this. It's going to be 33,500 minus 31,200. The value we get is $23,000. No, not $23,000. $2,000 and $300. $2,300. All right, nice. So, oh, this part actually did draw it because it saves more time, but I'm pretty sure you guys can draw this. This is going to be the median. This is the median. This line's the median. This is the upper quartile. This is the lower quartile. This is the maximum value from the from here. The maximum value over here is 368, and the lowest value is 300. That's why this is the same. We just keep drawing it. Very simple, guys. So comment on whether the mean or the median would be the better representation of data for the employees at Petrol. So what is better, mean or median? In most cases, in most answers, it's median. Now the reason why it's median is because if you look at the range of values here, right? This value right over here, 36,800, this is an outlier. Okay. Now, what is an outlier? Outlier means that means in the set of data there is a value that does not really match with the set of data. So over here, as you guys can see, that the values range from this to 34,100, but this value is way bigger than this range, so it doesn't really correspond to this range. It's an outlier. It's something. It's like a variable that should not be in the set range of data. Hence, this is an outlier. And if you have an outlier, you shouldn't really calculate mean because that's not going to give you the correct value of the average. Hence, median is the better approach here. Median is not affected by the outlier, while the mean is. You guys also should mention what the outlier is. 36,000. It's very easy to identify an outlier. Just for example, if you have a range of data like 1, 4, 5, 6, 7, but for example you have a value of 80. So guys, you tell me, what's the outlier? 80, right? Because this value does not match with these values, right? It's a very huge number, very big number, very unusual, weird, strange number that should not be in this range. That's an outlier, right? Very simple to identify. That's your answer. Next question we have is probability questions, probability distribution question. So Jasmine has a $5 coin, two $2 coins, and two $1 coin. She selects two of these coins at random. The random variable x is a total value in dollars of these 2 coins. Okay. So the value is $7. So how can we get $7? We can get one $5 coin and one $2 coin because that adds up to be 7. Okay, so what's the probability of this? $5 coin, $2 coins, $1 coins, where x is this? Okay, so how can we prove that the probability is 0.2? Okay, we can use combination here actually. Because look, they have one $5 coin, two $2 coin, right? And two $1 coin. And we're selecting out of two $2 coin, we're selecting one, right? So we can write this as 2C1, and out of one $5 we're selecting one, so into 1C1, so that leaves 2. So how can we find probability? Probability is this divided by total number of ways can be selected, which is 5. 1 plus 2 plus, yeah, 2 plus 1 plus 2, yeah, 5. So out of 5 we're selecting what? We're selecting 2, so 5C2. And 2 divided by 5C2 leads to 0.2. Hence shown that is how you do it. This is a bit tricky, not gonna lie, this is like a bit tricky, but if you guys know the concept of combination, it should be fairly easy for you guys. So now I have to draw the probability distribution table. Okay, so let's just draw this. So what can be the value of x? You can only see the value of x can be 7, and actually 7 is the maximum value. We cannot go more than 7, right? But we can go 6, we can go 2 plus 2 4, we can go 2 plus 1 3 as well, and we can also go 1 plus 1. We can also go 2. Right. So the possible values is either 2 or 3 or 4 or 6 or 7. For each step we have to use combination actually. So px. So for probability of 7 we already know that it is going to be 0.2. What about the probability of 2? Probability of 2 is that, okay, probability of 2 is $1, $1. So let's see, the probability of $2 is, out of 2 she selects 2, so 2C2, and then 5C2, which is 0.1. Hence this is going to be 0.1. For $3 she selects $C. Okay, so from $2 2 coins she selects 1, so 2C1, and out of $2 she also selects 1, so 2C1 divided by 5C2 leads to be 0.4. Okay, 0.4. And then for $4, again 2C2, because she selects 2 from 2 divided by 5C2, which is 0.1. So 4 is also 0.1. And for 6 you can just subtract from 1 or do it manually. So how can we get 6? Also guys, we cannot get 5 here. Don't think I'm just writing it seriously. We cannot get 5 here. We cannot physically get 5 because she has to select 2 coins. There is $1 5 coins, so it has to be more than 5, and the highest value is 6. It's gonna be less than 6. It's gonna be less than 5, but more than, you know. Okay, for $6 it's, you're gonna take 1C from that. Out of 2 coins you're selecting 1, so 2C1 divided by 5C2 is 0.2 as well. Okay, all right, this question is pretty, I would say, tricky. I mean, like, if you guys can understand the wording and how this works, then it's fairly simple, but you just have to, catch on what this question is trying, to suggest. Next question is find variance. So first we have to find the EX. Basically you multiply these two values, so 0.2 into 0.1, wait, plus 0.3 to 0.4, plus 0.4 into 0.1, plus 6 into 0.2, wait, then plus 7 into 0.2. add all them up. Should get 4.4, which is the x value. And now we have to find variance. Variance, again, we need the ex value, but we also need ex squared, which means you square this, which basically means 2 square into 0.1. Basically you square root this part and then you multiply that with these individually and then you add them all up. So 2 squared into 0.1 plus 3 square into 0.4 plus 4 square into 0.1 plus 6 square into 0.2 plus 7 square into 0.2. If you add them all up, you should get 22.6, and you have to subtract 22.6 from the square of ex, which is 3.24. That is your final answer. Okay, now we have another question. This is approximation to normal distribution. Okay, so the residents of Mahjing, somewhere in China or Japan, I don't know, were asked to classify their local bus service. 25% of the residents are classified as good, 60 satisfactory, and 15 as poor. Random sample is given 110. Use the suitable approximation to find a probability that fewer than 22 are classified as good. Okay, so first of all, this is binomial. We're gonna consider this as binomial because we need to consider it as binomial to find out the mean. So mean is NP. N is total number. Total number sample is 110. 110 to probability of success is 0.2. That's probability of being good, which gets to 27.5. And what is variance? Variance is NPQ. Probability of success into probability of failure into total number. So basically 27.5 into probability of failure, which is 0.75. Subtract 1 from 0.2, 0.75. We get 20.625. This is variance, sigma squared, not standard deviation. So don't just write this down during normal distribution. So now we do normal distribution as such. But over here it says less than 22, right? Fewer than 20. Okay, less than 22. But don't just rush into this math by this, because you have to use approximation. Since it's less, you have to subtract 22 from 0.5, so it's actually less than 21.5. That's how approximation works. Now we do normal. This is gonna turn out negative, so I have to, where again, root over 20.625, not just 20.625. That's variance. We get negative value of that's 1.32. Subtract 1 from here, which we get as 1 minus 0.9068, which we get as 0.0932, which is your final answer. Nice. Now, for a random sample of 10 residents of Mahjing, find the probability that fewer than 8 classified their bus service as good or satisfactory. Okay, so this is binomial distribution. Pretty simple since there is given a small sample. So 10, and it says good or satisfactory. So you have to add the probability since it's the or. So 0.6 plus 0.25, which is 0.85. Hence it's 0.85. So Px is less than 8. Just subtract this from 1. Probability of 8 or probability of 9 or probability of 10. Okay, we add all them up, which basically means 10c8 into 0.85 to the power of 8 into 0.15 square plus 10c9 into 0.85 to the power of 9 into 0.15 to the power of 1 plus 10c10, which basically means 0.85 to the power of 10. So if you add all them up, you should get 0.180, which is your final answer. Okay. Now, 3 residents of Mahjong are selected at random. Find the probability that 1 resident classified the service as good, 1 as satisfactory, and 1 as poor. Okay. So 1 is good, 1 is satisfactory, and 1 is poor. But we don't know at which order. Hence, there's gonna be 3 factorial of this arrangement, 3p3. So 0.25 into 0.6 into 0.15 into 3 factorial, which we get as 0.135. Pretty simple, guys. Moving on to the next question. How many different arrangements are there in the 10 letters we generate? This is again a permission combination question. Okay, let's write the word regenerate first. So there's 10 letters, so 10 factorial. There is 1, 2, 3, there's 4 E's, so divide by 4 factorial, since they're the same letter, and there's 2 R's, so divide by 2 factorial as well. This turns out to be 75600, which is your answer. Okay, now, how many different arrangements are there of the 10 letters in the word regenerate, in which the 4 E's are together and the 2 R's have exactly 3 letters between them? Okay. So first, exactly 3 letters. So between the R's, there is a gap of 3 letters, 1, 2, 3. Okay, so since there are 3 letters, the E's won't fit. So if we cross out the E's, 1, 2, 3, 4, and we cross out the R's as well, which letters are we left with? We're left with G, N, A, T. So out of these 4 letters, 3 are gonna be here. That's why it's gonna be 4p3. And this are gonna be together. 4 E's are going to be together. So let's consider 1, 2, 3. So this R, 1, 2, 3. If you consider there's a 1 unit over here, the 4 E's are going to be together. Wait, let me just draw this. Wait. So R here and R here, 1, 2, 3. Then the E's are together. There's 1 remaining. So we're gonna consider this as one separate group, and this as one separate group. This is one separate group. So these are basically 3 separate groups. Hence 3 factorial. There can be, internal arrangements, and we're gonna multiply this by this 4p3 that we got before. That should give you the value of 144, which is your answer. I hope you guys understand that. If you didn't, make sure to comment down below. I'll try to explain it any other way. Now, is this the final question? Okay, yeah, this is the final question. So find a probability that a randomly chosen arrangement of the 10 letters in the word regenerate is one in which the consonants G, N, double R, T, and the vowels A, double, all these E's alternate so that no 2 consonants are next to each other and no 2 vowels are next to each other. Okay. That means, okay, split indices looks probably that a randomly chosen spin with 10 letters in the word generate, which it says alternate. I mean, these numbers and these letters won't be together. They're gonna be simultaneously side by side. Okay, so let's first try to arrange the consonants, which is this. So how many consonants are there? 5 consonants. 1, 2, 3, 4, 5. Consonants G, N, R, T. These are the 5 consonants. Okay, since it's probability over here, we don't have to divide by 2. Since it's asking for the probability. So the 5 consonants can be arranged in 5 factorial. Plus, they're not going to be together, really. They're going to be different, so it doesn't matter. So of these 5, let's put gaps in between. 1, 2, 3, 4, 5. Let's put one gap here, there, here, 2. These star marks means the gaps. Okay. Okay. So the vowels over here, A and the 4 E's, are going to be in these gaps. So how many vowels are there? There's 5 vowels. So 5 is going to be 1, 2, 3, 4, 5, 6. Wait a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh wait, this part won't be included. That will bring 11 letters, but we have 10 letters. So out of 5, 5 is going to be included. So 5 factorial again for this. Or instead of the vowels first, the letters can be first either, right? So internal arrangements with this either. So plus 5 factorial for that. Hence the or, right? So plus 5 factorial. And now if you multiply all this, which means 5 factorial into 5 factorial plus 5 factorial, that should give you the probability for, not the probability, number of combinations. Turns out to be 28800, but it says probability, so we have to divide this. 28800 divided by the total ways can be arranged. Divided by 10 factorial. Since we're picking the letters at random, not looking for different arrangements, right? So the R's and E's are going to be treated as distinguishable. Right. So that's why we're not dividing by, whatever the same numbers are. We're not. Because we're picking the letters at random, not looking for a different number arrangement. So the R's and E's have to be distinguishable. We have to treat them as distinguishable. Right. So if you divide it by 10 factorial, we get the value of 1 by 126, which is your answer. Okay. Yeah, that's it. I think that I have done with the paper. I would say this paper was relatively hard. Some questions were pretty tricky. For example, this one right over here, pretty tricky. And normal distribution was also mid. This part could be tricky to some if you cannot, combine. So overall, this paper, I would say, was fairly tough. Not the toughest, but I would give him a solid 7 out of maybe 8, actually. 8 out of 10 in difficulty. Right. Actually, no, 7's better. Yeah, 7 out of 10 in difficulty. That's how difficult this paper was. But overall, I hope you guys understood each and every working of what I showed. If you guys any questions, any query, make sure to comment down below. I will be sure to respond as fast as I can. That's it. Make sure to like, subscribe if you're new to the channel, to turn on your post notifications so I can make more videos and you guys can find it out more as quickly as possible. All right. So yeah, that's about it. Good luck with your exams. I hope you do all the best. Thank you.